when multiple random variables defined on the same probability space are involved, an easy way to compute the expectation of one random variable is sometimes to compute it by iterative expectation. Iterated expectation is a fascinating way to compute expectation, actually. So basically, it says that you can compute the expectation of random variable x by first computing the conditional expectation of this random variable conditioned on another random variable y, and sometimes this can be an easier computation than directly computing the expectation of x. And then you take, since this is a function of the random variable y, let's call it g of y, we can then compute the expectation of this random variable g of y. So we compute the expectation of this over the distribution of y. To see an example of doing this in action, let's revisit the example from the previous lecture. Remember, we worked on the joint distribution of two random variables, which was uniform inside this triangular region between 0 and 1. Okay? And in this example, we computed, by the way, this is the uniform distribution. Random variables x and y are jointly uniformly distributed inside the triangle. And we showed in this example that the conditional expectation of x given y was 1 plus y over 2 as a function of y. Okay, so using iterated expectation, using this, we could compute this by taking the expectation over the distribution of y, over the marginal distribution of y, 1 plus y over 2. But this is nothing but 1/2 plus expectation of y over 2 by linearity, and expectation of y we have already computed. Essentially, we've already computed the marginal density of y in our example. So I will just write this down, and that gives us 1/3. Okay, so then the expectation of x is simply 1/2 plus 1/3 over 2, which is 2/3. So this is an example of how we can divide and conquer. In other words, compute the expectation of a random variable by conditioning first on another random variable and finding the conditional expectation, and then iterating by computing the expectation over that distribution. And we'll see many examples of this. We'll make use of it in many different probabilistic models throughout the course.